Hello everybody and welcome to today's session in the certificate programs in Python for Algorithmic Trading and Computational Finance. This is the introduction and overview session, and as the title suggests, it's supposed to introduce into the topics that are covered in these certificate programs, and it should also give you an overview in terms of what to expect. So in terms of the schedule, the study plan, also in terms of the delivery format, also in terms of what you can do on the Quant platform. So after this session, you should have a good foundation to get started with the certificate program, which is a 16-week program, 12 of which are a formal program where we have a schedule, and 4 weeks of which are kind of dedicated to practice and to preparation of the final project. We have quite a bit to cover today, so I'm going to dive here into my slide deck. I see the agenda. We have a total of 16 points there. I do a quick introduction, who we are, what we do. I will then introduce the program. We dive deeper into the single classes such as finance with Python, tools and skills, Python for financial data science, Python for Excel, for databases, AI in finance, Python for algo trading, Python for computational finance, and we again have new classes. This is what makes me really excited, that as we go, we add to the basis that we have reached new classes, new topics, and among others, we will have a new class on reinforcement learning in finance for this cohort. Then we discussed briefly the study plan, and one of the major parts of today's intro and overview session are the case studies and the demos. They are not meant as kind of like a tutorial or training session. They're just meant to whet the appetite and to show what to expect later in the classes. So they are like taken from different areas of the program, just should give you a taste of what to expect indeed. Then I briefly discuss exercise and test projects, something that we have added recently. And these exercise and little projects, they allow you to test yourself as we go, what your understanding is, and you can train the skills and acquire additional skills as we go. The user forum plays an important role because this is your go-to area when you have technical questions, and either myself or somebody else from the team, or even from the other delegates, of course, can then answer your questions. I will close with a brief discussion of the importance of practice. Quick introduction. We are the Python Quants. We focus since years on Python for finance, and we do quite a bit around this core topic. We provide services to hedge funds, banks, for example. We run events, London, New York, to name the two most important cities. We provide a certification, part of which is today's session. I've published a few books, and 2 more are in the making. I will talk in more detail about one with open source libraries. We also run the Quant platform with some 25,000 registered users, which is also the main delivery mechanism for the certificate programs. Training really at the core to spread the word, what you can do and how to do it best with Python in finance. The AI Machine is a project that we run since 2 years with a team in India. And these experts, seasoned software architects, have built a platform for the standardized deployment of AI-powered strategies. Of course, all is Python-based, plus additional technologies that are useful. For the first time ever during this cohort, we will give access to the selected delegates to the AI Machine. More details on this later on during the program. Here, the quick summary, the one-pager. So if you're interested in getting a concise overview, this one-pager might take 2 minutes to read and gives you quite a bit of background of what I've been just talking about. Here you see myself giving talks, and if you visit my private page, then you'll find many resources from talks. Most recently, for example, in New York, I've given 2 talks, or in London, or in other cities like Dubai, for example. So all the resources are hosted there. If there are additional resources, so not only slide decks, additional resources in the form of codes, you typically find them there as well. Here are the 3 books that are already published on the topic. The best-selling one is in the middle, Python for Finance, O'Reilly. This came out 2018, December, in the 2nd edition. It has grown from the first to 710 pages and has become, and I'm pretty happy about that, kind of a reference work, not only used by seasoned professionals in the financial industry, but also used these days at universities to introduce Python for financial analytics. My current book project, and we would see a bit more about that, is Artificial Intelligence in Finance, a Python-based guide. So this is in the making for O'Reilly, and more on that later on, because you will be among the first at all ever get access to like a raw and unedited first preliminary draft. So we just put it today on the Quant platform, and you will be among the first to get access to an early version. It's not yet completed, but there in PDF form. This represents already 280 pages. I run communities in London, in New York, and a few other places. The biggest one is in London with some 3,000 members, Python for Quant Finance, a couple of years old, also in New York. So if you want to become a member, feel free. We're always happy if new members join our groups. With our partners, we couldn't do what we do around the world and online. So, for example, the certificate is awarded in cooperation with the German University HTWSR, the University of Applied Sciences. So it's a proper university certificate, and it's also issued by the university itself. But we also partner with Fitch Learning CQF for teaching, events, etc. And also with Thomson Reuters, these days Refinitiv, in the areas of data and analytics, for example. So at this point, a great thank you to our long-term partners in this regard. So the program now, let's dig into it. The program itself is like, I'm almost inclined to say a huge one. So when we got started, we might have had only, with this particular program, maybe 50% of what we have today. So we have added over the years new stuff. We have updated the classes to take into account recent developments and new versions, let's say, from for packages, etc. So it's quite a bit to cover. And I know that many of you might be planning to study self-paced, which is perfectly possible. So the 16 weeks are kind of like a rough guideline. I've also added a header example study plan on our study plan, actually, because I know that many of you are seasoned professionals or have other commitments like full-time work, to name the most important one, and that not everybody can follow along the pace. So don't fear that you get lost. Everything is on the platform. Just should follow at least roughly the sequence of the study plan, if not the exact timeline. So that's the program, 16 weeks, thousands of lines of code, hundreds of hours of instruction, and also hundreds of pages of documentation. And with today's edition of AI in Finance, to get started in HTML, there are some close to 300 pages more that we just added today to the documentation for your reference. Here you see another summary. Of course, there are like Jupyter notebooks. And again, I added today like the 9 core Jupyter notebooks that are already available for the new book, etc. pp. So many resources. Some delegates feel overwhelmed when they get started, but don't feel overwhelmed. Just enjoy what you see. Just take notice of what is all there, and give yourself time to maybe not master every single detail at the first run, but time to enjoy it, and later on maybe revisit topics that you think are important and you haven't mastered yet. So also the practice phase in particular, and this is what delegates give us as feedback, is pretty helpful in maybe discovering like little holes here and there, or some potential to revisit materials that need to be studied a bit more carefully. So just enjoy it, have a look at it, and you know it's all there, and you basically also have, of course, indefinite access to your personal resources in this regard. Why Python for Finance at all, and why all this machine learning? Why now the book AI in Finance? And I think these are like proper questions there. And here are a few articles that I've copied into this slide deck from Financial Times. Is this one. So JP Morgan Chase is putting hundreds of new investment bankers and asset managers through mandatory coding lessons in a sign of Wall Street's heightened need for technology skills. I think the whole industry has changed tremendously, in particular over the last 5 years, actually. And even like in capacities and role where people mostly could get by with, let's say, skills in preparing a PowerPoint presentation or in using Excel here and there. These days, coding skills and data science, data analytics skills are required and expected. So when you have a look at many job postings out there in the field, they almost always mention Python. And here, seasoned professionals also need to get trained in this regard. So the coding training for this year's juniors, so this article is from 2018 already, was based on Python programming. And next year, the asset management division will expand the mandatory tech training to include data science concepts, machine learning, and cloud computing. Everything that you read here is covered in our program. So obviously, it's kind of like a good investment because the industry requires these skills today. Here is an article from mid-2019, graduates with tech and finance skills in high demand. When I was recently teaching at Miami University, this is something that I highlighted where I said, well, even if you're after a master of finance here, coding has become so important that you cannot consider it as some sidekick. You need to focus really on coding and need to acquire programming skills. So putting Excel or PowerPoint in your resume, this is here one of the conclusions, doesn't, oops, sorry, I didn't want to get on that, doesn't suffice anymore. So you need to have some proper skills in programming and in data science, and not only with like office suits or whatever you are used to these days. But the good message actually is that it's not too hard. So we have come a long way in terms of like how easy it is to get started, how good the tools are, how easy, for example, it is to set up a proper infrastructure and everything. So 10 years ago, this might have been much more involved and complicated, and the learning curve might have been even steeper, so with more frustration, etc. But these days, it's not too hard to get started and to get to a decent level. So this is the good message in this regard. It is required, and you're on a pretty good way to master these required skills in today's landscape. There is yet another one. Finance will need people who can work with robots as AI takes a third of jobs. So job seekers with expertise in artificial intelligence, machine learning, and data science are among the most in-demand candidates in finance. And this is now a little bit of a supporting argument for why we focus that intensively on AI these days. And by AI, I mean all the nice technologies and algorithms underneath it in terms of machine learning, deep learning, neural networks, also what sometimes is subsumed under data science. We also try a little bit of a separation, but data science and AI are hardly separable in this regard. So all these skills are so in demand that somebody starting out or working and want to make progress in the industry hardly have a choice like to go around these skills in this regard. There's a question, of course, everything that we do today will be is recorded, and will be made available online. That's for sure. And that's true for all the live sessions that we have. They're all recorded and put on the platform because not everybody is able to join every live session, of course. So finance with Python. Now we are in the middle of the program, meaning that we dive a little bit deeper into the single classes. Now that we might understand and agree that Python is a key skill, as well as machine learning, deep learning, AI, etc. in the field. Now what is kind of like the structure of the program? And finance with Python is the starting class that we came up with quite a while ago, because we had many delegates that said, well, I have a strong finance background, but basically no programming know-how at all. And we had other people who said, well, I'm a strong programmer, I'm a data scientist, but I want to now move into the finance field. And for both of these groups, or maybe we have a third group where we say, well, I have a little bit of programming, a little bit of finance. How can I level up my game? So maybe we think in terms of these three groups that I now mentioned. This is the class to get started. So we have a gentle introduction to finance, Python, and the combination of both. So this is indeed really meant to get started in this world. So covering financial topics, maybe reviewing certain concepts that you might have studied at university, but now getting on a formal level. Not too formal, though, but a little bit of formalism is necessary. And at the same time, see how these notions, concepts are translated into a math and B, into Python code. And once, for me, it's kind of like pretty easy to understand a formal concept when I have kind of gone through the code. So recently, when I was working quite more intensively with reinforcement learning, I first got into the code, and then I read like the theory behind it, a 500-page book about reinforcement learning. And for me, it was much easier to understand the rather abstract mathematical concepts and computer science concepts there, because I had like the experience already with the code already. Maybe I haven't had like the full grasp of the theory, but I knew how the code works. And for me, this simplified things. Maybe there are people who have the opposite experience. Well, I know the formal concept and now I understand the code fully, no matter from which side you come. This class is meant for everybody to get at the same baseline. I would say, well, we have a common language. We have seen how certain finance things look in Python. We have already seen kind of some of the major Python things out there. So this is kind of like our starting point. And this is also time-wise, schedule-wise at the beginning. So everybody should begin with this class. And the resources, when we look at the resources, and I will show this later on in some more detail on the Quant platform directly, because this is the example class that I used to show a bit of the Quant platform. This is that we have like documentation. So this is as PDF, for example, documentation for that class is some 160 pages. Then we have the video recordings where there's also code attached. And we have, the Jupyter notebooks that accompany both the written material as well as the recorded videos. So there's quite a bit of code, couple of videos, and lots of text that you have here as reference. So again, you might say, well, I'm more the theory guy. I start reading and then move on towards the code. Or I say, well, let's have a look at the code first, and then let me grasp the theoretical concepts there. This is up to you. I mentioned before, for me, having seen the code first sometimes works better. You have the choice how to move along here with such a class. Then we have the tools and skills class. So here, one of my all-time favorite quotes, Yamamoto Musashi. I myself doing like martial arts since decades. And here from this famous book written by one of the most famous samurais, he points out that in building a house, there is a problem of the selection of wood. It is essential that the carpenter's aim be to carry equipment that will cut well, and when he has time to sharpen that equipment. So here the equipment are tools and skills, right? The selection of wood might be the data and the code. So wood in this sense, right? So, but the equipment is at least equally important. So if you want to save yourself time, if you want to become proficient in programming, if you want to be effective and productive, you need to master certain tools and skills. Not all that you can put on a list with 100 bullets, but we try to focus here on the most important ones that equip you with what helps you in everyday situations, maybe in the 90% of situations that you might face. And when we have a look at what this means in particular, see here, my header, learning to use modern and proven tools for Python development and deployment. So this means then in the basics part, Python installation and environments on Mac and Linux, as well as on Windows. So at the very beginning, depending on your platform, you should decide for one stream there. So for the first three topics, we have 2 recordings each with different sets of resources, because the world is similar, somewhat similar, but not exactly the same. When we consider Mac and Linux, that's kind of like pretty comparable, not a big deal. But when you then move to Windows, or when you're coming from Windows, this might be slightly different. So Python environments Docker usage and cloud usage look slightly different depending on the platform where you're coming from. Throughout this set of classes, we recently added two special ones. Maybe we will have during this cohort a few more as well. So I haven't decided that yet. But throughout, there are like certain examples which are related to basic Linux tools and shell basics, etc. So here and there, we add things to the mix. But we have throughout, kind of like for every session that you find on the Quant platform, we have a specific topic, like, for example, code editing with Vim. And I know many people are not really used to work with a shell-based editor like Vim, where you have many shortcuts, and I say, well, we have moved on. We have different tools, more powerful tools, it might feel. But for example, if you want to work in the cloud and your favorite editor might be Sublime, and I use Sublime as well on all three operating systems, Linux, Mac, and Windows, then you might have the need for another editor, because you cannot use in the cloud, when you SSH to a server, you cannot use Sublime really there. So then there might immediately arise the need for a text-based, console-based editor, and my tool of choice is Vim. And many delegates who have gone through the program say, well, this was really kind of a great addition. And for certain things, I also use this locally. That's for sure, at least for me. Then I introduce here in another session like a lightweight tool chain, as I call it, like with Screen as a session manager, plus Vim, plus Q for logging and debugging, so that you can edit, you have persistent sessions, logging, debugging. Doc tests, unit tests are important when you do software development. Git version control is a topic. This is kind of in and of itself like a vast field, version control, but we cover the basics. So when you get started for yourself only during the learning phase, you will find here everything that you need to get started on your own there. Maybe later when you want to work in a team, there are additional things to master, but once you've mastered the basics, moving on is not too involved. If you then say, well, I've come up with this fantastic Python package, or my software solution for problem X, Y, Z, then Python packaging might be a topic that comes up. This means that you structure your code in a certain way, in a certain standardized way. You might then want to document your Python package for use by others. Then you might even host it, be it privately or publicly, when you want to open source your code. And what we have is also a couple of case studies that we have in this class here and other related areas. But the case studies, a few of them, are typically meant to kind of combine all these tools into a single comprehensive project. So that's the class here. From a technology point of view, we covered Jupyter. This is one of the major tools where we'll do a little bit about Jupyter Lab as well here, but Jupyter Notebook is kind of like the tool of choice in general. Python interpreter, then Docker containers. I will have a quick demo today with Docker containers as well. You see that this is all but magic. After our program, you should be able to quickly spin up Docker containers and test some stuff. And then also in the cloud. So firing up a cloud instance, A, is cheap, and B, is pretty quick. If you know what to do, it might take you 3-4 minutes and you fire up your own server. And with DigitalOcean, the cheapest server starts at $5 per month. I think this is affordable. And if you want to deploy, for example, an algorithmic trading strategy, I think there's no way around a proper cloud-based infrastructure. There's no way, from my point of view, that you should run a real algo strategy on your local machine, for example. The resources are similarly structured as we've seen before. Here we have the recordings to see a few more, and we have in this particular class like a set of gists where I've collected resources that are not meant to be executed on the Quant platform, for example. So here you might be directed to another repositories where you find, for example, scripts that you can reuse, etc. pp. So that's kind of the way this is structured. Then Python for financial data science. This is based on my book, Python for Finance. Here we cover the most important Python idioms, techniques, and packages for finance. In the basics section, we have data types and structures. This is something that starts already in week number 1. This week, then we have numerical computing with NumPy, data analysis with pandas, OOP, object-oriented programming. In the data science department, we have visualization, financial time series, input-output operations, and performance Python. And then in the mathematics department, we have mathematical tools. We cover stochastics and in some more detail, statistics and also machine learning. There is a special which is about dates and times, because this is in financial data science such an important topic. When you think of a financial time series, dates and times play, of course, an important and central role there. The structure of the resources is similar. So here we have the written documentation presented as HTML. Of course, you can always reference to the book itself in printed form. Many people prefer still printed versions these days, or you might have access to the learning platform from O'Reilly. If you are a subscriber there, you have access to my book as well. But in any case, even without a book, you have access to all the resources on the Quant platform. As before, written documentation, here the materials, then the recordings, as well as the codes that accompany the recordings, as well as the written materials. So this is typically, let's say, the triangle that we have: the written documentation, the recordings, plus recordings and/or live sessions, I must say, plus the codes, typically in the form of Jupyter notebooks in tools and skills. This is more like in script form, bash scripts, Python scripts, etc., that you can use and reuse in your own environments. Then we have Python for Excel. This is kind of optional, in a sense that I know that many people are interested in this particular bridge because they still use Excel at work or back home for, let's say, visualization or interaction, like as a prototype GUI environment, so to say. And Python can bring the powerful analytics to Excel in this regard. And this is optional in the sense that I also know that not everybody is interested in this topic. But with Excel Wings, and that's the good message here, we have a fantastic package available, thanks to Felix Zumstein here at this point, that we can use and combine easily and efficiently, both in the Windows and in the Mac world, Python with Excel. So that's kind of like a pretty interesting thing. Although I must say, in the Mac world, not everything works as in the Windows world, but we've come a long way here as well. So many things these days work in Mac also pretty neatly. So that's this particular class. Then, of course, databases, because data plays a role no matter what we have a look, no matter what you do in finance or in any other capacity. Data, of course, plays a role. And we added this also not too long ago, where we said, well, we should in some form, I mean, here and there we talk about databases, we show small snippets, let's say about SQLite, for example. But I thought we should have something more comprehensive and systematic with regard to databases. And this is that class here. So Python for databases, making use of database technologies to efficiently manage large financial data sets. This basically has some 8 sessions, I think, and it starts with introduction and motivation. So why think of databases at all? We can put data in a CSV file, right? But is this the best way to go about? In some instances, maybe it is, but not in every instance. Therefore, relational databases like MySQL and SQLite are covered here. Then NoSQL database like MongoDB. Then PyTables as kind of like a pretty fast, based on HDF5, I should say, as a pretty fast binary storage database that we have there. SQL Alchemy, which allows us to abstract from a specific SQL database and be called as a little bit of an exotic, but nevertheless pretty fast, and in some instances pretty useful, a columnar data store. And last but not least, there is a session about comparing all these technologies, for example, with regard to the performance. Yeah, this is about Python for database. Of course, an important topic. particularly if you work in a professional context. And here, similar to tools and skills, because this is more like handled as a tools and skills topic, we have the recordings. Here are 6 sessions, actually, as I see it right now. And we have the recorded sessions. There are like resources, but the major resources here are again put into a gist. For example, also a installed setup script, which you can use to set up your own cloud server environment, because installing all these database technologies and working with some large sample data sets is better done in the cloud, where you destroy your cloud instance afterwards, instead of like using your local machine and getting like lots of rubbish on your hard drive. So that's the reason why we focus here exclusively on like a cloud-based infrastructure. But at the point at which you are supposed to start with this optional class, you should be able to easily and quickly fire up a cloud instance and to make use of the resources that you find with this particular class here. Natural language processing is becoming more and more important in our field. We have a rather concise class here with like 2 sessions that covers the basics. So being able to process unstructured data source such as news, text, etc. at scale with Python. It is a concise class, is what I mentioned, but nevertheless, you get like during these 2 sessions, you get access to pre-prepared scripts with quite a bunch of helper functions. You see here, for example, a helper functions to clean up HTML if you want to process HTML pages, and many, many more of these helper functions. And after that, you should be able to process at least, let's say, static files of different types, like text, PDF, HTML, and, for example, to calculate sentiment scores, to create summaries, etc. So with like the code examples that we provide, you should get up to speed pretty quickly. So these are like the optional classes that I've just covered, such as Python for Excel, Python for databases, and natural language processing. There are even more materials. There's one optional series which I don't call a full class. This is, for example, about object-oriented programming. So if there's somebody say, well, I see that we cover OOP, but not really in depth, there are 4 more sessions which cover object-oriented programming in even more detail. So again, I didn't mention everything, but these are the major ones that you should consider in the optional department. Now, artificial intelligence in finance. And I told you just today, we have put up the raw and unedited version of my current manuscript of the book Artificial Intelligence in Finance. And the focus indeed here is on parallels and similarities between the financial domain and other domains. So here's one in the preface. You find this table 1 comparison of AI in different domains. And I wouldn't say it all started with card games, but this was kind of like a point where many people took notice, even outside the field, outside research, outside machine learning, let's say, where suddenly a company, DeepMind, came up with an AI agent which was able to play Atari games from the 80s. And many people like myself can relate to that, can play Atari games at superhuman level, and simply by reinforcement learning. So meaning that the agent learns itself, right? The agent knows that maximizing the game score is the goal. It knows what it can do. So like moving the joystick to the left or to the right, for example, it gets points and scores as reward. There might be some obstacles. So one of the major obstacles that the researchers ran into was kind of like planning and delayed reward. So if there's kind of like a direct correlation between what I do and the reward, this is kind of simple. But if I need to do something right now, which might have an effect, let's say 10 seconds or even 10 minutes later, depending on the game, this is what was kind of like one of the major obstacles. There are no risks, of course, in training AI agents playing a card game. So this is kind of a pretty good sandbox. If we then think of autonomous driving, this is a different story, right? We need not only some software, we need also a car on the street. The goal being safely driving from location A to B. And the agent itself, the software, can be trained in virtual environments. And the major example here is like steering a car through Grand Theft Auto, this popular game, but real world test drives are something that of course you need to do, and this is where it gets involved, right? Here in the virtual world, no risks at all, but once you put a car on the street, oh my goodness, many things can go wrong. And the approach here is rather punishment for mistakes. So whenever the AI makes a mistake here, turning right instead of left, braking too late or whatnot, then it gets punished. So it avoids punishment. A little bit different to the idea of card games where you just want to accumulate scores. And the major obstacle here, of course, is transition from the virtual to the physical world. So that's kind of the big thing. And risks are plenty, but to get started with, damaging property, harming people, even killing people. And unfortunately, we have seen already some instances here. So I'm pretty happy that when I move here down, that in the financial world, we only, quote unquote, have the risk of financial losses, right? So it's hard enough to lose money, but of course even harder if people are getting harmed or even killed by some AI agent. But overall, this is pretty similar to what we see in other fields. Like here in financial trading, we have a trading bot. It's a software. We maximize maybe long-term performance. I could have also say maximize overall return or whatever measure we have to come up with a well-performing trading bot. We can do reinforcement learning in a virtual trading environment. We have lots and lots and lots of financial data that we can use to this end. Rewards are financial return, let's say, or risk-adjusted return, or whatever you want to use here. And the obstacle simply is the world we are dealing with, right? It's not a physical world where we have physical laws. It's simply the market itself, the efficient markets, and maybe competition. If somebody else comes up with a better AI agent, with a better trading bot, I need to compete against them. But in the end, the benefits might be high, promising, and financial losses might be the only thing that I need to fear. Maybe on an aggregate level, thinking into the future, we might see systemic risks there. But for the time being, we can safely lean back, train our agent, and even apply it then in practice. So 12 live sessions are here, plus the roughly 280 pages at this point in time for the first 9 chapters of the forthcoming book here. This is one of the key charts for me of 2019. I've used it basically in every talk that I've given. And this whole AI in finance story for me is like a really far-reaching and fundamental one. So when we think back, it hasn't changed that much, that financial markets are basically information processing engines where we have lots of data, input data X here. So they work like a mathematical function. I have input X and output Y. But how this works, how the transformation here, how this function might work, F here, this is kind of like the big deal, right? To understand this is the holy grail in finance, right? Because this behaves in a nonlinear fashion, this is complex, this is changing over time. So not like in the physical world where once we have discovered physical law, we can assume that this holds true through time and is also independent of the place on Earth, let's say, where I want to check for this law. But in finance, it's different. Nevertheless, people behave through history, like in finance, that I say, well, let's assume that rational traders or agents in general, that they behave according to the following assumptions and axioms. If this holds true, so that's the major assumption or a set of assumptions, then people came up with simple and elegant theories. Let's say mean variance portfolio theory, the capital asset pricing model, arbitrage pricing theory, and the like. There are many, many to name, but these are, I guess, some of the popular ones which have survived decades up until now in the 2020s. Nobel Prizes have been awarded for simple, elegant equations where mathematical proofs might be half a page, or maybe 10 pages, the maximum. But unfortunately, finance is one of those disciplines where you hardly find empirical support for most of the core theories that you find in textbooks, undergraduate, graduate textbooks. So this is what I call brain-driven impunity myth. It all starts with brains, where people say, well, let's do some normative economics. This is how I consider the world should behave. If the world behaves as I think it should, then we can come up with this wonderful equation. And this is then what I call the impunity myth, in search of wonderful equations. This might be a fruitless search, actually. What do I mean by AI in finance, or I coined the term finance here with the AI in the middle? I think this is now the way back to positive economics. We focus on data and relationships. We don't have that much of like an assumption, set of assumptions that we say, well, this is how the financial world should work. No, we have lots and lots of data. So let's have a look how it works in practice. And don't let us assume something about it. Let's have a neutral look at it, and let's apply, for example, machine learning, deep learning to it. This means general, parameterizable, trainable algorithms that have a careful look at the data. And such a model might be able indeed to find the truth, quote unquote. So I use it here a little bit sloppily. But let's speak of relationships, right? If you say, well, interest rates go up, and then we might see certain effects. So maybe I have an assumption about that or an expectation, but the data might tell me the proper relationship. Many people say, well, this is all good, but deep learning algorithms in particular, neural networks, they work like a black box, right? But for me personally, I say, well, I rather have like a black box AI algorithm, which works well and which makes consistent profits in practice when I trade, as compared to another theory, which I fully understand and where I can pin down with pen and paper the proof, but which doesn't work in reality, right? But of course, I'm aware of problems like in terms of compliance and governance, etc. So I'm not saying that there are no issues. I rather say for me personally and for the companies I manage, this is my practical approach to that, and I would then rather take later care of compliance and governance. So you see, I spend like on these two slides, I spend quite a bit more time because I think this is nowadays at the core of our programs, and not only our programs, at the core of the industry itself. And you might recall the articles, the screenshots that I've used in the beginning to motivate this whole story. Now the core classes, Python for algorithmic trading. Here we have the foundations. So the foundations are given through the other classes, finance with Python, financial data science. Then we move on here in this class after the initial period to vectorized backtesting, prediction-based trading, event-based backtesting. In algo trading, we deal with real-time data and streaming, the Onda trading platform, FXCM trading platform, interactive brokers, Gemini, and also automation and review. Here we also have a selection of case studies that you can visit and revisit if you need to. In particular, this should build a bridge to the practical modules there. Practice module 1 is about your own strategy that you should backtest and maybe try to deploy, and the deployment itself is then practice module 2. And based on your overall experience, you then should come up with your final project, the research paper. So more on the research paper, etc. later on. So there's like a really comprehensive class, and we cover here quite a bit of ground in terms of technologies, platforms, APIs, approaches, strategies for algorithmic trading. My thinking since years is structured along 7 different layers. So it starts with the infrastructure. We need to have a proper infrastructure. Of course, we need to have access to financial data. To get started with historical financial data, to formulate your strategy, to do the backtesting. But once we get connected to our execution venue, to the broker platform, we also need, of course, real-time data. Not only historical data, this is just a starting point. Once we place our first trade, we need to be able to follow along in real time. This is, from my point of view, a conditio sine qua non in this regard. Then we have the trading code where we place, execute orders, and last but not least, automation. This brings along with it quite a few more topics and issues, and our whole project, the AI machine, is basically about deployment and automation in this regard. So these are the 7 main layers, and I haven't changed them for like years now. because it still holds true what you see here, of course, on a very abstract level. But we get started with the basics and we move through the single layers here. And maybe we have a couple of loops. So, for example, we have financial data, formulate a strategy, and do vectorized backtesting. Then we get back to the financial data, formulate a strategy, and do event-based backtesting. So this is a little bit different, but you will learn about the two different approaches, which are both useful and basically necessary in order to get all out of it here. Python for computational finance, that's the other core class. This is now about rocket science, financial engineering, about derivatives analytics. And you see here the overview and the basics part. We have market-based valuation. Also here we build on top, of course, on the basics in the form of finance with Python in particular. In finance with Python, we cover already many of the fundamental notions of derivatives analytics and financial engineering. So for this class, the finance with Python introductory class is even more important, I would say, than for the algo trading class, although it doesn't hurt for sure if you, no matter what you want to focus on, if you go through carefully through the introductory lessons there. Complete market models, risk neutral valuation, Fourier pricing theory. So these blocks build here the basics department. Then we have advanced topics, Fourier pricing with applications after we've mastered the theory. Then we cover how to value American options by Monte Carlo simulation. Then a general market model that is introduced here, which allows for stochastic volatility, also jumps, also stochastic short rates. That's already kind of like quite a powerful model for equity options pricing. Monte Carlo simulation then in this particular setup is discussed in another session. We then calibrate the model, the first more simple models, then general market model to option prices. We do some hedging of options. We have review and we also have practice. In particular, with regard to practice and review, we have also the a parallel class. So we have the, let's say, theoretical and numerical stream, which I just introduced. Then we have here the background, which supports all this. So in the book, which you should have available if you go through computational finance, because this is like the major reference, there you find all the theory, also many code examples that are at least to some extent discussed in the theory numerical class itself. But we also have in parallel here the practical class, which applies DX Analytics, the open source derivatives analytics library that I have open sourced with, again, basics, advanced, and special. You see this more or less, at least to 80%, I would say, runs in parallel with the theory and numerics class. So here you'll learn how to make use of the DX package, how to install it, how to make use of it. A quick start shows you already quite a bit. I will also have a demo, a quick demo for DX Analytics. Here in this particular class, another session, framework and model simulation is covered, European valuation, portfolios of derivatives, Fourier pricing as well, American valuation, stochastic short rates, again, derivatives portfolios. So we add as we go more to the story of portfolios. We can also model and value multi-risk derivatives. We cover here applied volatilities and calibration as well as hedging. And the final point here are complex portfolios. So it is quite a powerful library. It's an outgrowth of all the work that we have done in the field of derivatives analytics, like writing the book, teaching at university, applying this in practice for like an exchange, for a hedge fund in New York. And this is like the outgrowth of that in the form of our open source package. There's, of course, a comprehensive set of documentations, I would say, like plural, because this consists of a set of Jupyter notebooks that cover different topics. So let's say you're interested in like a derivatives portfolio and want to calculate risk statistics. Here, for example, this is the Jupyter notebook number 8 here, where you can get details to derivatives portfolio and how to calculate risk statistics. And quite a few more things. So we don't even cover everything that DX Analytics can do. It's quite a bit in there. So the documentation, which is publicly available, of course, gives you all the details that might not be covered in our class there. All out there, open source, available for you for immediate use. The library itself implements what is sometimes called global valuation. So we do a risk-neutral present valuation and calculate creeks for instruments, positions, and portfolios. So we, in a non-redundant fashion, model risk factors. Here you see the example 1, 2, 3. We might have single risk, multi-risk derivatives, European exercise, American exercise. We compose positions out of single derivatives, and different positions make up portfolios where there is taking account of netting effects and risk neutral discounting. The fundamental theorem of asset pricing is what is here at the core. We can do the discounting based on constant deterministic or stochastic short rate. So this is the schematic overview of DX Analytics and how it works. So pretty flexible modeling approach, and basically no limits in terms of like the number of factors or the number of instruments that you model. It's rather limited in terms of what exactly you can model in terms of derivatives and in terms of risk factors. But if there is some need, we have done this over the past, we can add additional classes here as well. Again, the pyramid here, it again starts with the infrastructure. We need financial data. We have models that need to be simulated. We have Fourier pricing, which allows us to do an efficient calibration. The calibrated model allows us to do a proper market-based valuation. And last but not least, with this model, we can then also hedge, let's say, more exotic derivatives. So similar as compared to algorithmic trading, we have this thinking in terms of layers, and this is basically how we move through the topics to end up with a calibrated general market model, which allows us to do proper valuation as well as hedging in a market consistent fashion. So the new classes, I'm pretty excited about that we add again new classes. The first one is about reinforcement learning. This won't start too soon, so we need a little bit of basis in terms of finance, also from the AI and finance class. The AI and finance class starts at the very beginning, kind of slowly. So and when we have kind of like the proper basis, we will get started with reinforcement learning here in finance. And here, like famous examples, one is the DeepMind paper published in 2013, which was the first one about their successes here with regard to the card games from the Atari 2600 console. And I think this is, this was kind of like the event that really brought AI in the form of deep and reinforcement learning to the general public, namely when DeepMind with this AlphaGo agent was able to beat the world champion in Go, which was considered to be like at this point in time 8-10 years away still, but progress is made pretty quickly in this field, and we can apply the lessons learned, the algorithms and the approaches to finance as well. So you can read already about this in chapter 9 of the AI in Finance book draft that you find already on the Quant platform. Then we have another class I'm also excited about, and we're working since quite a while with a coder from South America, a former delegate. He doing his final project. He built a really comprehensive and efficient backtesting package for Wonder, event-based package. And this is what among others, what we're going to discuss in the masterclass. And this is the class that finally leads to the AI machine, where I said already during the introduction that for the first time ever, selected delegates will get access to an instance of the AI machine and can test their strategies in this standardized setup. Of course, we want to get feedback here, want to learn, but primarily you should get the opportunity to in a professional fashion deploy and monitor and manage your own algorithmic strategies. But this is all and will be based on the Wonder trading platform. Now to the study plan. You have received already the link to the study plan, and this is something that lives. Sometimes I make even updates a few times per week. You see here the overview. Here the screenshot says as of 9th of January. I have, in the meantime, after I've made this screenshot, I've already updated the screenshot to accommodate new stuff that we have added to the platform and some minor changes. So here you see the study plan itself, focusing on the first 12 weeks. We have here Finance with Python, and for the first 2-3 weeks, as you can see here, we go in parallel with regard to the core classes, and then the core classes separate into 2 different streams. You see here the next column basically is the live sessions column, introduction and overview. Here and as we go, I will put the live sessions in here. Then you see here financial data science, tools and skills, AI and finance, this part, and the optional class. So we have discussed Python for Excel, Python for databases, and NLP. I said there is another one, OOP, 1, 2, 3. So you have 3 additional classes, although this is covered in some detail here, object-oriented programming. And it's also covered, for example, here based on event-based backtesting. So you find OOP in different cases, but just in case you're inclined to master this more thoroughly at the beginning, 3 additional. We have more add-on sessions available. Not everything that we have for you available is shown here, but this is what we would consider like a consistent, comprehensive study plan. And I point this out regularly. Even if you don't get every single detail that is covered, let's say in week 1, which is already quite a bit, don't despair. We will revisit, I would say 80-90% of what is covered in the first week, for example, in later sessions again. So as we move on, many of the things are like shown in a different context or from a different angle or are used in other setups. So I'm not saying that you should sloppily go over all the resources, but I know at the very beginning it might be a little bit hard to grasp everything that you are exposed to. And therefore I say, well, don't despair, just like not every detail might be equally important, and most of them are revisited, reviewed later on. And this is something that you will see over and over. We'll see many things a few times because repetition has proven to be one of the most useful learning approaches, for sure. Like what I mentioned before with regard to case studies or reviews and other sessions that we have that combine also many topics into a single one. So that's the basic structure. That's the study plan. And of course, this is available on the web. You have the link. Here's also the link in the slide deck. And you should make sure that at least once a week towards the weekend, or even better on a Monday, this is typically updated. You will, or latest updated, you should have a look at the study plan and see if you are missing out on something or if you've forgotten something. But we also have, of course, the orientation emails, which provide you a summary for the week itself. So that's for sure. So email plus study plan are kind of like your major guidance in this regard. Now we come to the case studies and the demos. I said it before, these are not meant now to do some training session or a tutorial. Everything that I'm now going to do is just to show what to expect. So I've picked certain topics, certain Jupyter notebooks, certain ideas, approaches, and things from the program that I said, well, this gives you kind of a good overview, but indeed just in terms of an overview. We have finished if you like, the introduction. Now we enter the overview part, and it should whet your appetite. It should make you like excited about what to expect and to see that maybe some things that might sound from the outside a little bit more involved, difficult, complicated, complex, not that complex after all. So that's the basic idea of the case studies and the demos. The first thing that I'm going to show you is the Quant platform itself and how to navigate on the Quant platform. You have received a link to a video which does this in some detail. So what I'm now going to do is just like I'm going to focus on certain topics there. It's not like a comprehensive overview, but I want to in particular show now for week number 1, when you get started, where to find certain resources. And once you know where to find resources, let's say for one class, the Finance with Python class, then you should be able to get to all the resources that you desire from the other classes as well. So let me get to the Quant platform. This is the login screen. Everybody who is signed up for our program should have such a login. I go here and click OK. And we have now this overview. And at this point, and I just want to quickly mention it, we have started like 2-3 months ago with like a new project, PQP 2.0 is how I call it internally, which is supposed to come up with a more modern infrastructure for the Quant platform and a redesign of the whole approach. But for our cohort here, the Quant platform in this form is kind of like your major place where you get all the resources and the codes and the videos and everything. Also execution capabilities for most of the resources, not for all of them. So this is now the Quant platform. But you should sometime soon, maybe let's say 4 months from now, maybe at the very end of our program, of our 16-week program, we will have PQP 2.0 available for all of us. So how does it look? We have on the left-hand side, we have the navigator for notebooks. You see here the header says, and I might zoom in a little bit, on the left-hand side here, this is navigation for notebooks. So you see here in my overview only folders. So on the highest level, on the root level, I don't have a notebook at all. But when I go, for example, to AIIF, this is brand new, and I go to chapter 1, you see here artificial intelligence in finance. So only notebooks are shown. This is not meant, sometimes there's a bit of confusion, this is not meant to work with other files. I'll show you the file manager in a second. So when I click on artificial intelligence, then it opens here a Jupyter notebook. But again, notebook is the header, and notebooks are the only thing that I'm supposed to look for to use from this part here of the panel. So I leave it open so that we have something open here on the platform. If you want to work with other files, then you can use the file manager. And in the file manager now, here on my root level, you see suddenly there are different files. There is a zip file, intro text, some Python scripts, etc. So this is what is available when you have a look with a file manager. This is not shown here under the notebooks navigation. And I can, for example, from here, do different things. I can double click, for example, on AlgoCert. You see, this is a Python file, import math, print math, square root. So this is a little example Python file that I have here for demo purposes. So this is already the editor that you see here. So you can do proper Python code or to this and other code editing, let's say HTML script or whatever you want to edit here. So this is an editor that is available. And you see here, new editor. This would open it as well. And I can do more with the file manager. In particular, when I do a right click and go to the context menu, I can delete this file, I can rename this file, I can make a copy. Here I can use some Git functionality. I can zip, for example, a folder. I can download the file. I can send the file to somebody else, and a few more things. I can create a new folder, new notebook, new file in editor, or I can export all files. So we are not kind of like in the business of locking you into our platform. We are here in the business of providing an open platform. And if you say, well, I've worked quite a bit on the Quant platform, now I want to export all my files, you find such a functionality, right? We don't use any proprietary standards that you cannot use locally or whatnot. It's all standard, it's all open. So feel free to work with it as you desire. But again, right click brings you to the context menu where you find most of the functionality here of the file manager. Then we have the task manager. In the task manager, you see no terminals running, and here you see artificial intelligence. That's one of the reasons why I left it open. There is now a Jupyter Notebook running. Here you see the Jupyter Notebook that I've opened before. I see also here on the left-hand side, artificial intelligence shut down. I could shut it down here, but I can also use the task manager to shut down this particular notebook. So notebooks need to be shut down explicitly because I show you when I close this tab, this is still running, you see? And here also it's running. But now when I shut it down here, then it vanishes. And you see here it has changed from saying shutdown to delete. So now the functionality will be to get rid of this whole file. This is nothing that I want to do here. So under Task Manager, you can manage your running notebooks and your running terminals. Then we can open a shell. So this is at this point, I think, not too important. With a shell, you can work then like within every other shell. So you see here only a few things, like I can use my regular stuff, home, algo, etc. This is not as important at this stage. Maybe at a later stage, this might be important. But if you, for example, I used to work with Git, let's say, to name just one of the popular tools, you can use Git here on the shell. You see Git is installed, but again, this is not really in focus right now. You're rather supposed to work with the shell in the cloud locally on your machine. Then we have here, let me close the file manager as well. I've shown you the major functionality. Then we have here also the user forum. And in the user forum, you see there are boards for Quant platform. So this is all around the platform. And if you have technical question, how do I use this or that tool, then a certificate program dedicated only to the program, Finance with Python, Python for financial data science, algo trading, computational finance, ZX analytics. So I think the most active one that we have here is Python for algorithmic trading. You see there are some new posts. This says just new. I have seen these already, but there's even a new one. So there's one when we started the session. So that's not really true. But that one, for example, I've seen, but I've answered, for example, by email. So we can answer forum entries by email, and be assured that when you post something in the forum, a question, no matter which board, we get notified by email. So there's no need to write an email that says, well, dear Eve, I've posted a question in the forum. Can you please have a look? We get notified immediately anyways. And for us, we have programmed the functionality that we can reply to such forum questions even from the phone, or let's say a pad that we use when we are on the go. So we try our best to answer questions within 24 hours. Usually much faster, but during the weekend or holiday period, let's say, this might take a bit longer, but we try our best to get back as quickly as possible. So that's the forum. Feel free to post a new topic. And here you see, for example, when I click on new topic, here you find here new topic, and then you can go here and say, this is my question related to the following code. And then you can even put in here a code snippet. Let me cancel. I should go to the next line. You can put here a code snippet which says something like print hello Quant platform. And you can then decide, for example, here Python for syntax highlighting, and then it puts in code here. So in particular, when you have longer passages of code, you should use the code pasting functionality, choose the proper syntax highlighting. This makes reading and discussing code questions much more easy. You can then say, well, let's have a look at the preview here and say, oh yeah, well, new topic. This is my question related to the following quote, boom, boom, boom. And that's all good. You can also, if you think this is helpful, upload an image, let's say a screenshot where you see a problem, but posting text, traceback and full code is preferred in any case to screenshots. If you think in addition to the text and to the code that you post, a screenshot might be helpful, here is the functionality where you can upload the code. So I cancel this now, but if I would say send, then it would be posted here in the forum. There have been a few questions. I'm just having a look at the questions. With regard to the study plan, somebody asked whether there are kind of like deadlines to hand in stuff. So we provide all this information during the program where when there is, we don't really have deadlines. We just expect things to come in at a certain point in time, but maybe working as a full-time professional, you cannot really plan to to hand in things at a certain point in time. It might take a little bit later, then you should reach out. But this is something that we kind of communicate in general during the weekly orientation emails or based on separate emails. And if there are some issues with regard to the platform, if you might have not received, for example, login credentials to the platform, or you face some other technical issues with the platform, this is something you should reach out via email. If you have login credential, can log into the platform, you should, in general, put your question here in one of the boards in the user forum. Pretty sure you find one. If you are not really sure where to put it, in particular for the certificate program, I think everything that doesn't fit really into the other boards should be put here in the certificate program. But if you have really issues logging into the platform or whatnot, please reach out by email. We will help as quickly as we can to set everything up for you. Yeah, that's the user forum. A few more words on that later on as well. Then we now enter like the trainings part. So this was all general, and there are a couple of things that you see here which are only relevant for myself to do some management here, but which is relevant for everybody is here the part my trainings. And you see, this is the brand new thing, AI in Finance. We have just put this up today, January 2020. This is work in progress, raw and unedited, and you should in particular also read not only the disclaimer, but here you see the table that I've discussed before. You should also read here author's note about the application of AI to financial trading and what other people think and how I approach this topic, really practical, and have my own opinions. And I like to be convinced otherwise. I know there are experts out there that would maybe criticize things that I argue and I show here. But again, I'm open for discussion, but with a little note of caution here, you should approach this particular text. But I promise that I show you the resources based on the Finance with Python class. And to get started here, you see Finance with Python. So whenever you read Finance with Python in the study plan, so when I go to the study plan, here we go. And whenever you see something that says Finance with Python 01 or 02, and here Finance with Python chapters 1 to 3, and in particular this chapters part, this is now here 1, 2, and we go down 3. So when you see chapters 1 to 3, this refers to this particular part here, Finance with Python. Chapter 1, Finance and Python. Chapter 2, two-state economy. Chapter 3, three-state economy. And here you find the resources with regard to what is mentioned in the study plan. Resources in written form, and also when I scroll down, there's some intro text, also mathematics as promised, but also simple Python code. I would really argue that the Python code that you find here is pretty simple. This is what I mean by a gentle introduction. We introduce financial notions on the most fundamental level. And the Python codes are also as simple as possible. The examples are as simple as possible, but nevertheless meaningful. And the Python code here, you see, is just like one step, one code line, another code line. So pretty simple. But this is, of course, not the only thing that comes with it. You should know this by now. We also have here Finance with Python in the next part. This is all written material that you see here. And here Finance with Python, this is now the class part containing the videos and other resources. So here, for example, I can click on such a video and it shows me the video Algo Cert session FinPy 01. So this is the first video. And here in the study plan, you see Finance with Python 01. And this refers to the first video. So exactly what I've opened here, the first video, is what is referred in the study plan. There is another way of opening it. You can go here and click on this. So this repeats itself. This is just like an overview of the videos. This is the same thing. But what you should notice, and I'm regularly getting questions where people say, well, I don't find like the resources that you use. You need to click here on the module header. This is a link. So when you click on Finance with Python 01, another tab opens. Here you might find more information or something here like a link to a PDF file. You again find the video. And importantly, here you see the attached files. So attached file here is 01 Finance with Python demo, 02 Finance with Python demo, 03 Finance with Python live, and you also find the slide deck here. So when I click on, double click, I must say, on this particular Jupyter Notebook, then the Jupyter Notebook opens, and you see now you have access to the code that accompanies the Finance with Python 01 module, and I can now go here and execute this code step by step. This is already executed, so usually, depending on the Jupyter Notebook, I post Jupyter Notebooks either in executed state or in a non-executed state. This depends a little bit on the content there. So, but I can now go here through the Jupyter Notebook and execute it. So I'll leave it as it is. But again, you need to click here on the blue header, Finance with Python. You see my cursor changes. When I click on that, module Finance with Python 01 opens, and this gives me access to all the resources, to the video, to maybe some links, and here to the attached files, and I can double click on these files. And these files also appear when I navigate back here later on in trainings. So here trainings, and you see there are quite a few trainings, and in particular what I'm looking for is Finance with Python videos, for example. So here Finance with Python 1, and here see my copies, and there is the demo video, the other demo video, and the live. So this is something you can access here as well. So first you open it here, then it automatically gets copied in your home trainings folder. Everybody should have such a trainings folder. This is where you find then later on as reference your files there without going to the module itself. So let me put this up. So these are now the resources. You have seen we have the written materials. This is what is here, Finance with Python left-hand side. I've opened this by a simple click. This is the HTML version. You also have a PDF version, and the PDF version can be accessed via the file manager. You go to FinPy. I have a few more folders here, so don't be irritated that I have quite a few folders here. This is just my working environment. And you find here under FinPy, this is a folder that you should have as well. You find FinPy course. This is password protected. You should have received via email twice the password, and here you then have like the PDF version. This is probably not nicer to be read on the Quant platform as compared to the HTML version. I really prefer online the HTML version, but if you want to use the file manager to download it and use it on your, let's say, iPad, you can here download this file, and then once you have it locally, use the password and then read it, see it, use it on whatever platform you prefer. So these are the resources here that are presented for Finance with Python, but the same holds true for all the other classes. You see here Python for Finance. There is the written materials. This is an early version of my book Python for Finance, second edition. Then we have here Financial Data Science. This is that class. You see all the videos there, data types and structures. And with these, you have kind of like here, Financial Data Science. You have data types and structures. This will be the first video. And you're supposed to read here Python for Finance chapters 1 to 2. So these are like the resources for this particular class. And you see, this is not exactly the same to 100%, but it is kind of like to a very large extent, it is similarly structured. I mentioned a few differences in tools and skills, but these differences are highlighted and explained in the class itself. So that much about the Quant platform, and you should get started. And if you have questions, post, and this is like the first thing that you should do, post your questions in the user forum and we get back as quickly as possible. So my second case study now is Python with Docker. Now, some of you might say, well, I've never used Docker. This looks like a magical technology that is pretty hard to master. If you want to apply it on large scale and professionally, this might hold true. But if you want to just get started with some simple stuff, this is not too difficult. I have Docker installed and running here on my machine. You see here up there is Docker running. Docker desktop is running. And on the shell, I can now use Docker. So this command starts a Docker container. I'm working here on a Mac, but I'm going to run Python in a Docker container, which itself runs Ubuntu. So this is what I do. So when I execute this line, which is posted also in the gist that accompanies today's session, you have received already the link to it. And now it says root. This is like the language already of Ubuntu or Linux in general. So I'm just like doing a little bit of a font resizing. Root at PyCert. So PyCert is now my name for our certificate programs in Python. This is the name of the host. And I'm here in my Ubuntu world. And when I type in Python now, well, it says Python command not found. And what I want to show you rather quickly, pretty quickly, is how to install it. First, I do a little bit of housekeeping. Apt-get update. This updates the package index. This is like making sure that we know what the latest packages are. Apt-get upgrade. So this is now to update all the packages. And it says now, well, there are a couple of them that should be upgraded, 11 here. Would I like to do it? I say, yes, I would like to do it. This should be rather quick. So now we have an updated Ubuntu version, and it's like a minimal one. Minimal meaning we don't have too many tools in here, like HTOP, for example, one of my favorite tools to manage resources, but I can install all the tools via apt-get install HTOP. To just show you one example, HTOP install, and now it is installed. And when I now type HTOP, you see the resource manager here is now running. It shows that I have access to 6 threads. The memory allocation is 2 gigs. So I get memory allocated here 2 gigs and 1 gig of swap actually. But my machine has 32 gigs. So you see the container manages resources. I have also here on my machine 6 cores, 12 threads. So I only get half the threads and just like 2 gigs of 32 gigs here for my container. So this is what I can check. But my point here was more that in the container I can now work as if I would be on a proper Linux machine. I want to install Python with you, and installer of choice is for us Miniconda. After the program, you will have done this quite a couple of times. I go to the page. There you find the installers for Windows, Mac OS, and Linux. I'm using here the 64-bit. I copy the link address, getting back to my container. And let me check. I have not installed. Now I really have a need to install wget because that's a tool I want to use to retrieve the file. Yeah, so another tool in addition to htop. Now I have wget and I paste here the link for Linux. Again, Docker container, Ubuntu, my machine Mac, but this is not a deal. And it retrieves now this file. This should have some, I don't know, 70 megs, 80 megs maybe, yeah, close to 70 megs. I have retrieved it. Let me have a look. I'm here in the root. There is miniconda latest, blah, blah, blah. And now I say bash miniconda. Now here, should we continue? Yes, we should continue. And I go through all this. I say yes to the licensing terms. The installation default is okay for me. It's now installing Python. Yes, it should prepend. So I say yes to everything. Now, again, we have this larger package. I can remove miniconda. This was just used for the installation. When I go to root now, I see I have one folder live. This is a mounted volume and miniconda. Here now Python is installed. But it still doesn't find Python. I need to restart my bash. And when I restart bash, you see now it says base. The prompt has changed. And now let me check whether I have Python. And indeed, I have Python. And I can say print hello delegates. So the first line of Python. And you see, this just, I was talking quite a bit, but the downloading and the running of the script and now being able to execute Python, this were just like, I don't know, maybe 2 minutes if I hurry up, and I have it available. So in addition to base Python, I can of course install other stuff via conda install. Let me install IPython, NumPy, and NoMKL. NoMKL is a meta package. So IPython is a tool. NumPy is one of the major packages that we are going to use. This is for numerical Python. Here I say yes. I'm now installing a very popular command line tool and a very popular numerical package. And the first one I start via IPython. And here now we have IPython, we have Python 3.7. I can now import NumPy as NP. And for example, I can draw, random, a bunch of random numbers, for example. So we are in the game, and you saw this just a few minutes. And when you have done this a few times, it feels like second nature. And you fire up a shell, you run maybe a Docker container, or you fire up a cloud instance, and you run on the shell there as well. You download miniconda, you install it, you install your packages, and I'm pretty sure when you have mastered the program, this really feels like second nature, and you can quickly set up a proper Python environment. And later on, you also learn, for example, how to clone environments and how to make stuff like this even a bit more efficient. So this is the message here. This might sometimes sound a little bit hopeless, so to say, but it's all but hopeless. So we show you in detail, both on Windows as well as on Linux and Mac, how to do all this, what I was walking through rather quickly. So that's the infrastructure part. Now, a very important topic, efficient markets, which is important both for computational finance as well as for trading, because it is playing a dominant role in both fields. So I open here Jupyter Notebook now locally, my Mac, maybe I zoom in a bit so that you can better read it. And again, it's not a training session, not a tutorial, I just walk through this. And the basic idea of random walks is, when I cast this in a least squares setup, is that the best predictor of tomorrow's stock price is today's stock price. So in other words, there's no point in analyzing historical data if efficient markets hold true in, for example, trying to make some profits out of technical chartist analysis, let's say. So that's the basic idea of the EMH, which dates back to the 60s and 70s in particular. So here I retrieve data. So we're in the middle of financial data science here. I retrieve a data set, end of day data for a bunch of symbols like Apple and Microsoft. I see here some 2,138 data rows. I calculate the log returns. I can do some plotting, which has nothing to do with the efficient market hypothesis yet. But you see here the data visualized using Plotly in a nice interactive fashion. I have here nice Hoover effects. I can zoom in, for example, with Plotly. This is all nicely done and nice to apply in such a context. I have two more plots. The one is a histogram of the returns. So this is, for example, something where we could discuss normality of returns. Obviously, none of these time series have normal returns. Maybe correlation might be of interest. Here we see a heat map of the correlation matrix. And here, for example, S&P 500 in the middle, SPY is the ETF on the SPX. So we have here already quite a few popular financial plots. Now I prepare lag data. Again, not the details are important here. I lag the data. I do a regression analysis. Details are presented, I think, for this particular topic a few times in the program. And here are the important results. So I have lagged price data, and for every single RIC, Reuters instrument code, or symbol in general, I see that the regression, in order to predict tomorrow's price, just gives today's price, like number one, as the best predictor. So indeed, the efficient market hypothesis, when I approach it the way I do, and there are a couple of weak points here, the way I'm doing it, we violate, for example, a few major assumptions of ordinary least squares regression, but NumPy doesn't complain about that part. But we see here, basically, just today's price is obviously important to predict tomorrow's price. And when we have a look at the visualization of all this, we see it kind of like impressively demonstrated and illustrated here that we have only some weight of around 1 for the most previous lag. You see orange is lag number 1. This is the most previous lag price that we have available. And all the others, the price from the day before, the price from 2 days before, etc., they are not important. They have weights around 0, and this looks like numerical errors basically. And here we have, on average, the picture is even more clear. So just lag 1 has weight in the regression and everything else has no weight. Again, this is a little bit of an analysis with some weak points, but the message, I think, is clear. We have found some supporting evidence here given our data set of a number of different asset classes with their time series for the efficient market hypothesis. And it is one of the theories, after all, which has the best empirical support that we have. So, and this is what computational finance, rocket science, financial engineering makes use of. So that's the next use case here, calibration. When we deal with models to value derivatives, options, the basic idea is when we want to implement a market-based valuation that we assume that markets are efficient. It means that in this particular case, the prices for options that we observe in the market, at least in liquid markets, for liquidly traded plain vanilla options, are the right ones. This in turn means that when we have a model such as here, something that we discuss in detail in the program, the Merton-Jump diffusion model, which has a couple of parameters, that the correct approach to get a market-based valuation is to have a look at the market prices and come up with parameters that best reflect the market prices. Because where's the point in a model where I have chosen personally, let's say, arbitrarily, some parameters, I assume something here, and the prices that I get from the model are absolutely out of sync with what we observe in the markets. There's no point in having that. So market-based valuation, again, starts with the prices that we have in the markets, and then we try to figure out parameters for these models that best replicate the markets that we observe. And this is what this Jupyter Notebook is about. We make heavy use of efficient markets. Here, characteristic function. This is all about Fourier-based pricing. These are all helper functions explained in detail in my book, Derivatives Analytics with Python. And we will see many more examples in this regard. Now, a numerical example, when we combine these functions, we can value an option. What I do here is like, I would say, a parameter-based valuation. I personally come up with some arbitrary parameters, right? These are the parameters that are relevant for the valuation, and I simply do some assumptions here. But calibration is different. Calibration means we have, and this is here in the formula, we have market prices, and we try to minimize the mean squared error, the root mean squared error, whatever measure, whatever distance measure we want to have, given all the market prices relative to my model prices. So this is what we do here. I now go through this data set here. You see we have data from September 30th. We have call prices here shown. We have put prices. We have also the majority, is a short majority, 17th of October. And when I visualize the prices here, you see, yeah, this is like increasing. This is for calls only. You see call prices. The higher the strike, the lower the price. Now we have here the error function, root mean squared error. And I do here now a brute force calculation. And this is like a computationally demanding process where we try, via iterating over different parameters in a brute force fashion, to minimize the error value. So this is all about minimization. And you see it's running, takes a bit. 400 evaluations, 500, and you see here, this was the minimum value, 0.9. And here we see the final value after the iteration. And you see there's no guarantee that we are getting better and better. So in the middle part here, we might have found already the best parameter constellation, but this is like the nature of brute force. We simply iterate over all allowed combinations and pick the best one. And when we have the best one, we then move on and do a local minimization based on some gradient descent approach, for example. And when we reach a certain level of tolerance where we say, well, that's good enough for us, then it will stop the optimization. You see, it's improving slowly, slightly, and from 0.97 we end up with 0.767. And the optimal parameter values now here are 12.5, 6, etc. After the second iteration, you see they have changed a bit, not that much. And I can now plot, that's the major thing here, and we see that my model, these are the red dots, gives me not the exact same values as I observe in the markets. This would be a little bit too much to be expected from a calibration, but the differences are not too high. So the largest difference we see here is something like minus 1.5 euro. This is in euro, this is in absolute terms, right? Here, just by visual inspection, we would say, well, it's exactly the same, right? But we see here, of course, there are differences. But the differences are not biased. So we have model prices that are too low, others that are too high. So we don't have a biased model here. This I would consider is kind of good result. With different, more sophisticated models, we can do better. But the basic question here is, if efficient markets hold true, we should calibrate the parameters of our model to best replicate the prices here of liquidly traded options in the market as possible. That's the message. So let me restart and clear that output. I'm going to save that. Also the efficient market one, I can here restart and clear to reset everything. I mentioned the DX Analytics package. That's the next one. You see, we are moving here through the demos, efficient markets, model calibration, DX Analytics package. Here's the next demo, DX Analytics. And not going into details, just walking quickly through it. We have this class. So the previous example about the calibration, this would belong to the theory numerical part of the computational finance class. And this, of course, belongs now in the DX Analytics part, where we address similar topics, but we make use of the library of the package DX Analytics, which frees you, of course, of writing all the code that we have seen before. Not of everything that might be relevant in a certain context, but certain routines are simply there and you can use them out of the box. Here I import DX and a few more things. I have my risk factor model that I come up with. Is a simple geometric Brownian motion that I use here. The first one, then, for example, I can do some visualization of my simulated paths. I simulate a second one, the major difference being higher volatility. So this has a higher volatility than the first one. Then I do some valuation here of an American put on a single risk factor. I can calculate numerics like delta, gamma, vega, theta, and rho. So this is how powerful DX Analytics is. Although there are no closed formulas for these Greeks for American options, making use of numerics, of numerical methods, we can work with such an object as if we would have a closed formula. Of course, we need to take into account numerical issues here, but it works from an API point of view as if you would have analytical formula there. So the second derivative is a European call option on the second risk factor, and it works now as if we would be in a Black-Scholes Merton world with all the analytical formulas that we have available. Then I can put these two risk factors plus the two options into a derivatives position first, and then the two positions into a portfolio, and then I can simulate and value the portfolio of derivatives. So here, see, I have two American single options, the value and the position value, three European singles, just to make an example. And on a portfolio level, I can also calculate the position delta as well as the position vega on a portfolio level. So not only on a single instrument level, on portfolio levels, this works as well. Here, some risk reporting. These are now the deltas. This is like a what if or a scenario analysis. And this works with Vegas as well. Here you see, for example, I have here the benchmark value, and you see for the factor that I'm considering, there is a net effect of 0 because I haven't changed anything. And if I change the factor by plus 5%, then we see how Vega increases here, 3.4 and 0.8. Or not Vega, sorry, the portfolio value. The portfolio value, I increase Vega by 5%, and we see here the effect on the portfolio level. And the same holds true here when I say, well, I decrease the volatility value by 20%, then I see like how the value of my portfolio drops, depending on whether I go with the first risk factor or the second risk factor. So this is how flexible DX Analytics is. More details, of course, in the class, in the respective class. So restart and clear output. A little bit of housekeeping. Saving that one. And the next one is market prediction. Now we move into the algorithmic trading area. And efficient markets play a different role here. So before, in the computational finance part, efficient markets are our friend, as I explained. So we say, if markets are efficient, we should come up with parameters of our models that best reflect, when applied to the model, the market prices. But in trading, I want to generate alpha. So I want to beat the market. So what is my friend in computational finance is my enemy in the algo trading part. So we apply now different methods. When I applied simple ordinary least squares regression, I saw that, well, the best predictor for tomorrow's price is today's price. So that's a little bit boring. So I don't need to do any analytics. If this is the insight, no kind of like analysis is worth the while. Therefore, here, this is part from AI in finance and algo trading. We try now to predict the market based on some machine learning algorithm. Here I work with data. This is now not end of day data. You see here, this is intraday data. We have much more data as compared to before. We had end of day data 2,000 plus rows. Here we have 15,000 plus rows. I add to the mix a few more financial features like volatility, simple moving average, momentum, all explained in the class. My data set is divided into training, validation, and testing. I work with 10 lags. Here I do Gaussian normalization. Then I lag and normalize my data via this function, and I have 210 columns. So these are all my features. I now come up with a deep neural network from the scikit-learn package. I instantiate such an MLP classifier object. MLP stands for multi-layer perceptron, or we can say deep neural network. And I'm fitting now my AI model, my neural network, to the historical data. Just the training part, you see here I'm using only the training part. Now I do some vectorized backtesting, and the backtesting now takes place on the test data set. Right, here you see test. I train on the starting part here, but now the testing takes place on data that the model has never seen before. So this is test data. I backtest it, and you see here for my little test case, the model goes most of the time short, and it's just to a minor extent is long. And you see the blue line here is how the underlying performs. This is a currency, euro, US dollar. And my trading strategy, without leverage, without transaction costs or whatnot, performs over the same period of time with plus 5% something. And the underlying, the passive benchmark investment here, loses some 3%. So we have an outperformance, unleveraged, no transaction costs of some 3 plus 5, some 8%. If you leverage this up, let's say by 10 only, FX you can do much more, then we would have some 80% again without transaction costs. This is just like the idea of discovering statistical inefficiencies in the markets. With ordinarily scarce regression, we weren't able with the end of day data to discover any inefficiency, which would have given us an edge beyond the insight that today's price is the best predictor for tomorrow's price. But here, applying a neural network to the data set, the way we do it with quite a few financial features, obviously we are at least able to discover statistical inefficiencies. If we want to move on towards economic inefficiencies, we would need to add to the mix transaction costs, as well as, like, first of all, there must be a strategy that allows me to implement all this. And second, we must factor in transaction costs, maybe financing costs when we use leverage, and the like. This is about statistical efficiency, and this is how the book AI in Finance is structured. After the basics, there is a part about statistical inefficiencies, and then there comes the part about how to exploit such inefficiencies to make economic profits. But let us assume now that we have such statistical inefficiency. You might say, well, and how and where can I trade such a strategy? Yeah, we need a platform. To do that, we need a broker. So let me, as before, clean up house a bit and close it. Now for the first time, we see a platform, Wanda platform. So you heard me talking about the Wanda masterclass. It's also part in the core class in algo trading. Let me open the web interface. Here, this is now a demo account, a paper trading account that is pretty easy to be set up. You are later on supposed to set this up as well. It's all for free. I think no strings attached, and you get basically a fully working real-time trading environment. You see here there is some position during a recent demo that I've opened. This has made some decent profit here. It's kind of nice, but this is not my major point. I simply leave it because it's in the green. I've opened this only to show you now when I go through the Jupyter Notebook that when I execute a trade, this will appear here in my positions list. So on a trading platform, you need to install TPQA for what we do here. Some standard packages are required as well, but TPQA is what we need. Then you need to have credentials. Everything in this regard is explained in detail both on the page of TPQA as well as in the class. And I connect here to the API. I retrieve the instruments available. So I just show here 4 of them. There are currency pairs, there are credit instruments, there are commodities, there are indices, like 128 instruments, I think, depending on the jurisdiction that you can use there. So I go with the Euro US dollar, what I had for the prediction before. Here I'm retrieving 1 minute bars for just like a pretty short period of time, 1418. And now I'm implementing a momentum strategy, pretty simple stuff here, just calculating the returns, the momentum itself. It now says unexpected error while saving file. I don't know what's up with that one. Let me quickly try to reload that. We weren't that deep in. Something happened here. I don't know what happened here, so maybe let me restart. Let me restart Jupyter Notebook. So here we are. I've restarted Jupyter Notebook. Just need to get to the right place, back where I was, and now wonder. This hardly ever happens. So from my experience, fortunately, I must say, Jupyter Notebook is pretty robust these days, but there's no guarantee that it works all the time as desired, as we have seen. So I wasn't that far in. So here I have the strategy. The hit ratio of my strategy is calculated here. You see falses, trues, and the hit ratio is, well, we are more often false than we are true here with my little strategy, which is a simple momentum-based strategy. And when I calculate this, my hit ratio is below 50%. And people generally say, and I like to say that as well, that the baseline prediction is 50% because so the accuracy ratio is 50% because even if I toss a coin, I should end up with 50% of the time correct trades and 50% might be losers, right? So when I predict the market direction, it can only go up or down. And if we have somehow equal distribution, then 50-50 is a baseline. But this is only one side of the coin, of the trading coin. Here I calculate now the profit because it's not only important how many predictions I get correct, but rather which ones. We all know that the biggest movements in the market, like upwards movements and downwards movements, are the important ones, not the small ones. I rather care about the big ones. And you see here this little strategy is not working too bad. So I'm not saying you should follow this strategy or whatnot, but I just wanted to make the point. Even with a hit ratio below 50%, you nevertheless can make a decent profit if you get the important movements, the big movements correct, right? So here you see the strategy. So it's short, it's long, it's short. So it changes the position quite often. So now, without going into details of deploying the code, here we see now how easy it is to execute a trade. Now for Euro GBP in my example, to show you that there are other instruments as well. Euro GBP, units 100 and minus 100. So plus 100 means I want to go long, minus 100 means I want to go short. And in my trading account, as you can see here, in my trading account, here there is only this one long position from before. When I now execute this one trade here, you see I get back this larger JSON object, and in my account, my paper trading account, a second position is now to be seen. Euro GBP, just 100 units long, and you see from the outset we always have a little loss because it accounts already for the bid-ask spread. So this is what we see here. So immediately it has executed it, and it shows up here in my Wonder trading app. So when I want to close this position, I go short 100. I open the 100 for 100. Here I sell 100 and get back like the similar object, and it has vanished here. So as simple as this, you see a single line of code, we place orders and we close positions. We can then also inspect transactions. Here you see this was the most recent one, just that one that I placed Euro GBP plus 100 minus 100. So this is something that I did before, but the last two ones here are the relevant ones. Also, via this API access, I get streaming data. So let me stream maybe 7, let's say, and I get real-time data here, tick data for Euro US dollar. Also, a prerequisite when I want to implement algorithmic trading strategies, because again, backtesting, all is good, we need it, we should do it, but historical data based used for backtesting is not enough for me to trade. I think this is clear for all of us. So here, stream data allows me to stream data for every instrument, and then, for example, to collect the data, to generate signals, and to place orders. We know how to place orders. We now have seen how easy it is to stream data. And if we combine all this and put our trading logic around it, we are in the game of algorithmic trading. Yeah, that's how simple and straightforward it is today, I must say, given all the technologies, packages, etc., that are now available here at the beginning of the 2020s. Here with a regular notebook, be it Windows, be it Mac, be it Linux, Ubuntu, you can do all this if you have mastered the basics. There's not that much more in this regard. So I'm going to close that one. I think I should reload that one here. My last little demo is about the new class reinforcement learning. And this is an example that has established itself as kind of like the introductory example. And I used it as well in chapter 9 of my new book to introduce reinforcement learning. And it's wonderful that we have also packages available here that allow us to easily replicate what other people have been doing before. Here, it's a card pool game. Now you might say, what is that? Yeah, this is like the problem or the game of balancing a pole on a card that you can move to the left or to the right. Speaking of left or right, we have two actions, 0 or 1, that we can choose. So here I can sample an action, 0, 0. When I repeat this, there might come up a 1. Here's a 1. It took me a while. So 0 and 1 are the two actions. Move to the left is a 0, move to the right is a 1. I show you a picture of it. So if you don't have a clear view on what I'm talking about, bear with me a few more minutes, then you see a picture of it. Observation space. Now the question is, how is the world described? What is our world? And for the AI agent, we just have an observation space with 4 parameters. Here we see the maximum value for the parameters, 4.8 or infinity, minus 4.8, minus infinity, etc. And when I reset the environment, I get like semi-random numbers here. So this is like now my world. For the AI agent, there is no kind of real representation of a card or of a pole or whatnot. So it's really abstract. It's just like 4 numbers. And the 4 numbers are card position, card velocity, pole angle, and pole angular velocity. Now let us take an action. We can take a random action and I take the environment one step forward. It's not a real-time environment. It's an asynchronous environment. Only when I take an action here, take a step, then the environment changes. And now I show you like a random agent, and it will show here embedded, or I can show you this here as well. So now you see the card, and there is the pole. And if the pole leans too much to the right or to the left, then it falls down. That's clear. And then we get a failed here. So I can try it again. I don't know how long it survives, sometimes a little bit longer. This looks better. So in the first time, after 18 actions, it failed. Here, second time, 30 actions, it works. Now it's 29. So, but I think you now have a good view on the game itself. It's a card, it's a pole, and you just can move it left or right. Now we apply something here to the problem that is like a very powerful instrument and approach in reinforcement learning. This is dimensionality reduction. We have 4 parameters. And what I do now, I take like a linear combination to reduce the dimensionality from 4 to just 1. So I have chosen random weights, I apply a dot product, and from my 4 parameters, I end up with just 1 parameter. What is the importance of this 1 parameter? I use this 1 parameter and I define an action policy based on this parameter. I say if this single parameter S is below 0, I move to the left. If it is above 0, then I move to the right. So the objective is now, here in this particular case, to learn weights by brute force, by Monte Carlo, to survive 200 steps. And to this end here, for example, I try my best now with the random weights, and I only get like 10 steps. This is not good. Let me try one more here. So I randomly draw 4 different weights. Maybe these are better, if not perfect. This is fantastic. I already found one, because 200 means success. So whenever I find something, 200, this is where the problem, as they say, is solved. Here I apply Monte Carlo simulation, where I redraw random numbers as often as I need to. These are the weights that the machine says might be good ones, and now I test the results. And indeed, I have found weights that give me here over 100 episodes, an average of 200 actions, 200 reward points. And this is considered success. So when you read the documentation of this game, it says, if the agent has an average of 195 or higher during 100 consecutive episodes, then the problem is considered to be solved. And now we can go here and have a look at the, here it is. It is now playing with it. I was just looking for that one. It is now playing with it, and it went through. So when I redo it, you see here now state, 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 state. It survives, it survives, it survives, and it works, and it works. It reaches 200 with the weights that I found. So we haven't discussed the details, but be assured you will see all the details in the classes, in the materials, and in particular in the now book draft that is available since today. So that's just to whet your appetite that we have nice and fun examples in this particular regard. This fun example here is about card pole. Very simplistic, but you will also see an example where we apply a similar approach to a financial context, where I come up with a model with a class that mimics here the card pool game, so that after the card pool game, you see, oh, well, this is like similar to how I can model the financial world, and then you can apply similar methods there as well. So fun examples, and the whole thing is fun, if you ask me. So be assured we together will have also hopefully some fun here with regard to reinforcement learning in this new class. So this ends the demo part here on the trading, reinforcement learning. Of course, reinforcement learning then applied to finance. We have throughout, and before there was already a question when to hand in stuff, there are certain milestones where we ask you to hand in test projects, for example. But first things first, we have 4 blocks of 3 weeks, like for week 1 to 3, 4 to 6, 7 to 9, 10 to 12, we have sets of review questions. These are not meant as exercises nor as projects. These are just like guidelines where I came up with sets of questions which address, from my point of view, the most important notions and concepts. We say, well, let me get through these questions and see if I've understood what we have covered. So there are 4 different sets of such questions, differentiated in the computational finance core class and the algorithmic trading one. So when time comes, week 4, for example, you will get a link to the set of questions for weeks 1 through 3. Then we have the exercises and test project. This is now something which is beyond thinking, where you are supposed to come up with your own code. So we have different types there. We have review exercises. This is something slightly adjusted as compared to what you have seen before. We have transfer exercises where you should redo something, maybe in a slightly different context. And then we have test projects, which might be requiring a little bit more effort, which might address completely new stuff, where I think this is either fun or important. And for most of the exercises, and I emphasize most, not for all of them, in test projects, there are example solutions available that are presented both as Jupyter notebooks or codes, as well as during recorded sessions. So why only most? Because my experience previously was that, people know, there will be example solutions anyways, right? So I don't need to really work too hard. So Eve will present the solutions in the next session. That's true for 80, 90% of the stuff, but not for everything. When we ask you to hand in something, you should come up with your own solution. That this is meant to be a test for yourself for like the final project, where there will also not be any kind of reference benchmark or whatnot. So you should get used to the fact that you are here to gain practice and to generate your own wonderful Python codes. So there are 2 examples. This is the very first test project. It's also a fun thing. It's a game that you are asked to implement here with relatively simple Python codes at the beginning. Then we have finance with Python. There are like this is like I would say a repeat exercise, so to say. The example is pretty close to what is shown during the session and in the material. So, but nevertheless, it gives you the opportunity to rethink what you have seen there, as well as to review maybe certain elements of the program that you might have skipped over in a first run. So these are just 2 examples, very first exercise and very first test project, but more on that later on as well, of course. The user forum we have discussed intensively. Make sure that you make heavy use of the user forum, and you can also search the user forum. If you have a question, maybe it's good to first search for similar problems, issues, questions. And in any case, you can post your questions 24/7, and we try to get back as quickly as possible. Please, from experience, have a look at this particular web page. Stack Overflow, when we have maybe a few hundred or thousands of questions and posts and snippets, they have millions and millions and millions of programming related posts there. And from their experience, they've come up with this wonderful little post there, how to create a minimal, complete, and verifiable example. You should put yourself into the shoes of somebody who is supposed to answer your question. Sometimes we have on the user forum a question that is like, in session X, Y, that, I saw ABC, I tried to implement it in exactly the same way, but it does not work, period. What can I do? So from experience, whenever I read exactly the same way, I know it's 99.999% of the time not exactly the same way. Therefore, for you as an exercise and for us to make it much easier and quicker to help you, please have a look here at how to create a minimal, complete, and verifiable example. Make use of the code posting capabilities there with proper syntax highlighting. This speeds up and simplifies things considerably there. So minimal, use as little code as possible, still produces the same problem. Complete, provide all the parts, maybe data as well, make it verifiable, test the code you're about to provide to make sure it reproduces the problem. And there is a bit more in this post, but these are like the basic messages. Please make sure that you review this particular post there. Importance of practice, the very last point for today before I leave you to cover the topics of week number 1. So when you look at how people are trained in the professional and business worlds, you find a tendency to focus on knowledge at the expense of skills. Be assured that you will gain lots of knowledge based on what you see in the program, but the focus for you should lie on acquiring skills. So this is really when I, for the first time, read this book and listened to the audio version of it, which really opened my eyes to some extent. Where I said, well, that's really true. Like if you master 3 things properly in terms of skills and implementation, efficiency, productivity, it's much better than to know about 100 things, but you might not know how to best implement them. So I believe, and this is here a quote, but I could, these days I can say that as well. I believe that the best approach will be to develop skills-based training programs. Training should focus on doing rather than on knowing. If you have to decide and to prioritize whether to read a few more pages or one more reading assignment as compared to do a proper exercise or test project, I would always go with the exercise and the test project, where you, of course, have the freedom and flexibility to still refer to the documentation. That's for sure. But again, in case of doubt, prioritize skill acquisition over reading through the materials. And that's kind of like the good message here from the same book by Anders Ericsson, Peek the Secrets of from the New Science of Expertise. No matter which area you study, music, dance, sports, competitive games, or anything else with objective measures of performance, so put in here programming, data science, machine learning, this all fits pretty well in here. You find that the top performers have devoted a tremendous amount of time to developing their abilities. So interpreted from one angle, this means that don't expect that after 5 hours of careful reading and 2 hours of a little bit of programming, you are already black belt level. But on the other hand, this is kind of what we see here as an insight. It's kind of like also calming us down in the sense of that everybody else that you might see, that you might know, who is already at black belt level, has put in a tremendous amount of time in developing the skills. And I, for myself, I can say, well, my endeavor started well more than 10 years ago, where people say, well, this looks so fluent when you type code live and here and there. Yeah, but I do it all day, every day, all over the year, and I do it since a couple of years. So, and there are people out there that are much more proficient in many of the areas that we cover, for sure. But the message is nobody out there is kind of like a natural talent. Everybody needs to put in the work, the hard work. Finally, this is what I want to close with it, because this is something that really makes me even a little bit proud and happy when I get such feedback. And this is what would be my wish for you, how you should feel after the program. So when they say, well, I like watching your videos, but it's much more interesting and educational to actually build something on my own. And we all know this. If we, as kids, solve the puzzle or build our own castle or whatever we were interested in, this was really what gave us like the pleasure and the joy. And this is with programming as well, from my experience. You can read like hundreds of pages, but if you crack a hard problem on your own and you figure out the puzzle, this is what really brings you excitement and enjoyment in this context. So having said that, I wish you a perfect, wonderful, exciting start into the program. Make use of the user forum. If there are issues, technical nature with regard to accessing the platform, the resources, write us an email. Beyond that, please use the user forum and have like a good, relaxed attitude, more like an explorer. Explore what you will see, explore what you will experience, and yeah, simply enjoy it. I'm pretty sure after the enjoyment, you will see the practical benefits and how this all will bring you forward personally as well as professionally. I see you in the next session. Take care. Bye-bye.